Hey guys, these notes are for direct variation. Our essential question is how can I tell if an equation or graph represents direct variation? We are in Unit 3b, and Unit 3 is basically about lines and different forms of lines and different types of linear equations. So we've learned previously about three different forms: slope-intercept, point-slope, and standard form. Direct variation is a special kind of linear equation because it's kind of like slope-intercept form. It looks really similar, and I hope you notice that later, but it's a special kind of linear equation that goes through the origin, or better known as the point 0, 0. Okay, so if I had a graph like this, then my line has to go through 0, 0, so it's either a line that looks like this, or maybe a line that looks like this, or like that. So any line that goes through that point. So if you want to think about it, you can think about it like that. So let me go ahead and draw like a little example for us here. Okay, so it has to go through the origin. It has to, in order for it to be direct variation, which means that its y-intercept has to be 0. Okay, so what does the direct variation equation look like? Well, the direct variation equation looks like y equals kx, or y equals mx. It looks very similar to y equals mx plus b, but our b is 0, so that's why we don't write it. So it'd be like y equals mx plus 0 because, well, you don't really need to write plus 0. So, but we're going to refer to it as kx, just so that we don't get those two mixed up. So we're going to use y equals kx for direct variation. Now, the k is kind of like our slope, but it is also called the constant of variation. So direct variation is y equals kx, and it's just a special name. It's a very fancy name, but all it's really saying is that the y-intercept is 0. That's the really only special thing about it. The constant of variation is also known as the slope, so it acts like a slope. So instead of y equals mx, we have y equals kx. So if I ask for the constant of variation, I'm asking for k. And the reason why we don't call it slope is because you don't find it the same way you find slope. So that's why we don't call it slope and we use k for it, okay? Now to find k, you would do y divided by x. Okay, so it acts like a slope, but it's not really a slope if you're thinking about it in terms of finding it, okay? And that's the special formula to find the constant of variation, or k. And so I would remember that, and I would try to memorize that. So we're going to use that formula for these next few problems. Determine if the tables represent direct variation. If it is, give the equation. Okay, so let's first determine if this is direct variation. So tables are represent direct variation if their k is constant. Remember, constant of variation is our k value. Constant means the same, okay? And to find k, you would do y divided by x. So let's go ahead and look at the first table. We have the point 9, 3. Well, let's go ahead and do y divided by x here. If I want to do k equals y divided by x, what's my y? My y here is 3. And my x is 9. What does that simplify to? 1/3. Okay? Then you check for the next point. Same thing. So you're not finding the slope, you're finding k. K equals y divided by x. So our y here is 2, and our x is 6. So y divided by x would be 2 divided by 6, which simplifies to 1/3. Then our last point in the table is 3, 1, but we always put y on top, right? Just like with slope, y is always on top. So we do 1 divided by 3, which just equals 1/3. So what do you notice about all of your k values? They're all the same. K was constant. It's the same. Constant. And you don't have to write constant, but because they're all the same, this does represent direct variation. So I'd say yes, it does represent. But then it also says to give the equation. Give the equation. Well, your equation here, well, you know that it's y equals kx. So what is our k? Well, our k was 1/3. Okay? And you know that it's y equals kx. So you would have y equals 1/3 x. It's just kind of like finding your slope and you plug in the slope. So it's going to be y equals 1/3 x. That's our equation for the first table. Now we can only make an equation if it represents direct variation. If it doesn't, we don't need to make a table, not a table, an equation. Whoops. Trying to move this stuff over. Okay, so let's move on to the second one. So I want to remember that to find k, it's y divided by x. Remember, y is always on top. So let's go ahead and start. The first point here, we have 1, 5, but we want to do y divided by x. So 5 divided by 1, which is going to simplify to 5. The next point is 2, 4. So we have 4 divided by 2, because y goes on top. 4 divided by 2 simplified is 2. 3 divided by 3, so because they're both the same, so it does, y goes on top still, but regardless, there's still 3 on either side. So 3 divided by 3 is 1. And then lastly, we have 4, 2, which means I'm going to have 2 is my y value and 4 is my x value. 2 divided by 4 is 1/2. Well, what do you notice about all of your values? It's not constant. They're not the same. Remember, constant means the same. Because it's not constant, that means it doesn't represent direct variation. So this would be no, and there's no equation because it doesn't represent direct variation. So, okay, because it does not have a constant k, right? K has to be constant, then it doesn't represent direct variation. Okay, so there's an example of where it is and where it isn't. All right. Next, we're going to find if the following equations represent direct variation, and if it is, what is the constant of variation? So, again, direct variation looks like what? The equation is y equals kx, okay? We want it to look like y equals kx. That means that we can't have a y-intercept. No y-intercept. Y-intercept has to be 0, so I don't want a number over there, okay? I just want to make sure you get that in your head. All right, so y equals kx, what letter is by itself? The y. Y is all by itself. So in all the equations, you want to get the y by itself. So the first thing I'm going to do is I'm going to draw my line to solve my equation. Okay, now, right now my y is almost by itself, but 3 is being multiplied to y because I have 3y. So to get y by itself, I need to do the opposite and divide by 3. But when I divide y by 3, I have to divide everything by 3. So I divide 5x by 3 and negative 9 divided by 3. 3 divided by 3 is going to be 1, so that cancels. So I just have 1y equals 5/3 x. And then negative 9 divided by 3 is negative 3. So what's my slope here? My slope here is 5/3, right? This is just like y equals mx plus b form, right? So our slope is 5/3. What's our y-intercept? 0, negative 3. Is that 0, 0? No. So, does it represent direct variation? No, it doesn't, okay? So, if yes, you tell me the constant of variation, but it's not, so we get rid of it, right? Moving on to number 2, 4x equals 5y. I notice that my y is not by itself, so we want to go ahead and get it by itself. The first thing I'm going to do is, well, I notice that the y is on the right side, but that doesn't really matter to me. I still need to get the y by itself, so I need to divide everything by 5. Okay, 5 divided by 5 is 1, so I have y over there. And then I have 4/5 x. Okay, so I have 4/5 x equals y. And again, it just looks a little funny because it's a little backwards, but that's okay. So what's my slope here? Remember, slope is always attached to your x, so our slope is 4/5. And then what's my y-intercept? Well, there's no number being added or subtracted, which means my y-intercept is 0, 0, right? And if you want to write it the other way, right, or y equals 4/5 x, right? There is no y-intercept. There's nothing there. Well, direct variation just means I don't have a y-intercept. So, does this represent direct variation? Yes, it does, because my y-intercept is 0, 0. That's what matters. So it says, if it is, what is the constant of variation? Remember, the constant of variation is your k, and k acts like the slope, right? K acts like the slope. So what is our slope in this problem? 4/5. That's our k. That's our constant of variation, okay? Moving on to number 3. 3x minus 2y equals 0. Go ahead, because we know that y is not by itself, so we're going to have to solve this for y. Okay, the first thing I'm going to do, you always want to add or subtract before you divide, okay, or multiply. So the first thing I'm going to do is I'm going to subtract 3x on both sides. So subtract 3x on both sides here. 3x minus 3x is 0. Negative 2y equals, well, 0 minus 3x is just negative 3x, right? Just makes negative 3. Like 0 minus 3x is just negative 3. Okay? Now you can write 0 minus 3x, but you don't have to write the 0 because it doesn't make a difference. So it's just going to be negative 3x. And then I want to get the y by itself, so I would divide everything by negative 2. Negative 2 divided by negative 2 is 1, so I have 1y equals negative 3 divided by negative 2 is positive 3 over 2, and then I have an x. So what is my slope here? Well, my slope here is 3 over 2. What's my y-intercept? 0, 0. So, does this represent direct variation? Yes. Remember, if it has a y-intercept of 0, 0, that's direct variation. That's all that matters when I'm talking about equations and graphs. So, if I said yes, what is the constant of variation? You want to remember that the constant of variation acts like the slope, okay? It acts like the slope. So, what is our slope in this problem? 3 over 2. And I'll actually even write that over here. Constant of variation, constant of variation. It acts, oops, wrong day of notes. It acts like slope. Acts like slope. There we go. So we have that bit. All right, on the next page, we're going to write and solve the direct variation equation for each situation. Okay, now these are word problems, but don't let it scare you, right? I tried to break this down into steps, but instead of like saying, is this direct variation, it's going to tell you that it is direct variation. And it's going to tell you that by saying something like y varies directly with x, or y is directly proportional to x, something like that. So if it says y varies directly with x, it's just basically saying y equals kx, our direct variation equation. That's what y varies directly with x means, okay? So number one, if y varies directly with x, okay, so I see y varies directly with x. Remember, I know this is direct variation because it says varies directly. So I know y varies directly with x means y equals kx. I know that. And then it says, and y is 36 when x is 4. What is y when x is negative 2? Okay, the first step, anytime it says direct variation, is that you need to find your k value. Well, how do I find k? Remember, k is y divided by x. So I'm going to use some information that it gave me to find that. Well, it said y is 36 when x is 4. It told me that. So let's go ahead and use that information. It says y is 36 when x is 4. So let's put that in the formula. K equals 36 divided by 4, which equals 9. So that means that k equals 9. Okay, that's the first step. But because it's not my final answer, I'm going to go ahead and circle that. I found my k. That's always the first step when it says this is direct variation or it varies directly. You want to find your k value first. The second step is write the equation. Remember, direct variation looks like y equals kx, right? So it's just like if I give you y equals mx plus b, I want you to plug in the slope and the y-intercept. So what did we just find? We found our k value. And I don't like how Notability changed my box or my square and my circle into like a rectangle. So anyways, so our k value was 9, so let's go ahead and write the equation for that. That would be y equals 9x. Okay, so that's my equation. So the first step, you find k. The second step, you write the equation. The third step is you're going to solve the problem. The problem is, what is y when x is negative 2? So it says y question mark when x equals negative 2. It wants to know what the y is because we don't know what y is, and it tells us that x is negative 2. So using our equation that we just had, what information can we plug in? Well, I know that x equals negative 2, so let's plug that in. Y equals 9 times negative 2, so y equals negative 18. That's the answer to the problem, okay? It gave us all that information, but we had to get that information and slowly get it to our answer. So the first thing I notice is it says varies directly. So that means, okay, y equals kx. I know that. Then it says y is 36 when x is 4. That's giving me information to find my k, because k equals y divided by x. Just like slope, you have your y on top and your x in the bottom. Okay, the next step is to write the equation. Well, you know your equation is y equals kx, so plug your k in. Y equals 9x. And then you're going to solve the problem. So you're looking for y when x is -2. So that's why I plugged in -2 for x, so that I could find the y value. And our y was -18. Okay? So it's not too bad. It's a lot more thinking and a lot more words than you're used to, I think. Or it's just anyone's used to be honest. So it can just be a little overwhelming at times. Sorry, I'm trying to change this to green without having to erase all that hard work just to do something like that. All right, so next question is, suppose y is directly proportional to x. So like I said, sometimes it won't say direct variation. It'll say y is directly proportional to x. But that still means y equals kx. Okay? It's just like if it was saying, write this equation in point-slope form, then you go ahead and write down point-slope form because you know you're going to have to write it in that form. Okay? Then it says, if x equals 12 when y equals 6, what is the value of y when x equals 80? Okay, so I'm given lots of questions, lots of things. So what is the value of y when x equals 80? So let's tackle this one at a time. How do I know this is direct variation? Well, it says directly proportional or directly vary. So something that says directly is going to tell me, okay, no y-intercept, so not y equals mx plus b, but y equals kx. Okay, so I got that down. The first step is I need to find my k. So find k. I'm going to find k. Well, k equals y divided by x, remember? So what is our y in this problem? Our y is 6 and our x is 12. So they told us that at the very beginning. It says x is equal to 12 and y is equal to 6. So let's go ahead and plug that information into our formula. The y is 6, so y is going to go on top, and then our x is 12, so that's going to be in the denominator. And that simplifies to 1/2. So k equals 1/2. That's my k value. So the second step, you want to write the equation. Well, my equation would then be, remember, it looks like y equals kx, so plug the k in. So y equals 1/2 x. That's my equation. The last step, let's solve the problem. Well, what do we know? We know that our equation is y equals 1/2 x, right? We know that. But let's use this equation to help us solve this problem now. Y equals kx, not kx, 1/2 x. Okay, it says what is the value of y when x equals 80? Okay, so let's go ahead and try that. So value of y when x equals 80. So we know x is equal to 80, and it says what is the y value? So we don't know the y value, but we know the x value. So let's go ahead and plug in what we know. Well, we know x is equal to 80. So let's plug in x to the problem. So then we would have y equals 1/2 times 80. Whoops. Right? Because we know that x is equal to 80. So what does y equal? Sorry, I keep changing colors back and forth. Well, y is going to be 1/2 times 80, which is going to be 40. So that's the answer to my question there, is y equals 40. Okay. On the next ones, we're going to graph the direct variation equations. Again, you want your equations and you want direct variation to look like y equals kx. You want it to look like that. That means I want a y-intercept of 0, 0. Well, number one, I have y equals 3x. I know this is direct variation because the y-intercept over here is 0. They don't write plus 0 because it's just a waste of space, because adding 0 doesn't change anything. So I want to graph this, so I would identify my slope first. My slope here is positive 3 over 1 or negative 3 over negative 1. And my y-intercept is 0, 0. So the first thing I'm going to do is I'm going to plot my y-intercept. Okay? And I'm going to use my slope. I'm going to go ahead and use that first one. So it's going to be positive 3, so I'm going to go up 3 and then to the right 1 because it's positive 1, and then up 3 to the right 1. Again, when you're graphing, I only need at least 3 lines, so I'm going to go ahead, or not 3 lines, 3 dots, or 3 points. So I went ahead and just did 3 points there. With number 2, we can't already just start graphing because our y is not by itself. You have to get y by itself. So the first thing I'm going to do is I'm going to subtract x from both sides. Okay, so I have negative 4y equals 0 minus x, which is just negative x, right? Okay, then I'm going to divide both sides by negative 4. Negative 4 divided by negative 4 is 1, so I have 1y equals, okay? Now, what's the number in front of x? Well, it's technically negative 1, right? So I have negative 1 divided by negative 4, which is positive 1/4 x. Okay, so that's very tricky because we do tend to miss stuff like that because of those double negatives. So I'll maybe put a star next to this one just so that we know and we're careful about it. And actually, I'm going to make the star green so that I can show you where the scariness is where that green part is. All right, so let's go ahead and identify our slope. Our slope here is positive 1/4 or negative 1/-4. Our y-intercept is going to be 0, 0. Okay, so this is direct variation because our y-intercept is 0, 0. Plot a point there for 0, 0. I usually actually do these in separate colors, so let's go ahead and get that into separate colors. Use my first slope, so it's going to be positive 1, so up 1, and positive 4 to the right 4. And then I'll use the other slope. That's going to be, we start back at the origin where we started. We're going to go down 1 and then to the left 4. All right. Okay. All right, and then these are our last two problems for the notes. Write the direct variation equation for the graph shown. Again, we want it to look like y equals kx. So remember that direct variation is y equals kx. And then after we do that, we're going to find the value of y when x equals 3. So let's go ahead and look at both of these graphs, but let's look at the first one first. So looking at this first graph, I know this is direct variation because it crosses the origin. It crosses 0, 0, which means that's good. Now, if our direct variation equation is y equals kx, I just have to figure out what k is. But remember, k acts like a slope. K acts like the slope. So let's go ahead and find the slopes of these graphs. So let's go ahead and start. I'm going to start at this point. Remember, you can find slope between any 2 points. I just want to start there. So to find the slope, remember it's rise over run. So let's do our rise. So our rise would be positive 2, so up 2, positive 2. And then I'm going to the right 1, which is going to be positive 1. So it's positive 2 over 1, which means our m is 2 over 1. But remember, it acts like our k value. So k is going to equal 2, right? It's going to equal 2 as well. Whoops. Man, my iPad is just going crazy. So k equals 2. So what is my equation? It's going to be y equals 2x. That's my equation. Now it's going to say, what is the value of y? Well, it says, find the value of y when x equals 3. Find the value of y when x equals 3. So we know that x equals 3. So let's look on our x-axis for when x equals 3. That's going to be right here at positive 3. So we're going to trace that all the way up until our line hits the line drawn, okay? It hits that point right there. So we want to see what the y value is at that point. What's the y value here? 1, 2, 3, 4, 5, 6. It hits the value at 6. So when x is 3, then y is 6, okay? So that one you just have to use your line. So over here, we're going to do the same thing. We're going to start with our equation. So I know this is direct variation because it crosses 0, 0. So let's go ahead and first, I know it's going to be y equals kx. I need to find my k first. So remember, slope is rise over run. So I'm going to pick a point. Let's pick 0, 0 to be our starting point here. So our rise here is going to be positive 1. And then our run is 1, 2, 3 to the right. So that's positive 3. So our slope here is 1/3. But remember, that acts like our k. So k equals 1/3. Remember, our constant of variation acts like a slope. Okay? So that means that my equation would actually be y equals 1/3 x. We want to plug in that k value that we just found. So just like the previous problems with the words, right? I would want to find k first, right? I want to find k and then write the equation and then solve the problem. Same thing we're doing here. We're going to find k, that's what we've been doing, find k, write the equation, and then solve the problem. The problem is, find the value of y when x equals 3. Well, I know that x equals 3. So looking at my x-axis at 3, okay, I want to trace it to the line, and I traced it. So we want to see what the y value is. So let's go to the y-axis. So let's look over. It hits at positive 1. So that means my value of y is positive 1. So those are super, super like easy to miss because it's just like, you feel like it's so easy, like it can't be right. So it's just one of those problems, like just really think about it and be like, yeah, it just wants me to look and see what the y value is. So let's go ahead and just review what we did. So we talked about what direct variation is. Again, it's just a special kind of line that goes through 0, 0. That's the only special thing. The y-intercept is always 0, 0. And if it isn't, then it's not direct variation. Okay, direct variation is y equals kx. And the k is called the constant of variation, and it acts like a slope. So if they say to find k and they want you to write an equation, sometimes you just have to find the slope. Okay? Now, if it says to determine if it's direct variation, that's when you have to do the tests, right? So you know that the formula for k is y divided by x. So that's when you would take your y and divide it by the x and see if it's constant. And if it's not constant, then it can't be the constant of variation, so it's not direct variation. Okay? On these next 3 pages, you're doing the same thing. You want it to be y equals kx. You don't want there to be a plus b there. If there's a b, then it's not direct variation. So with number 1, we have a b value of -3. So that cannot be direct variation because it has to be 0. But with number 2 and 3, our b was just 0. There wasn't a b over there. So that's why it's considered direct variation. All right. With these types of word problems, these are the ones that you're most likely going to see on the STAR test. So you just have to remember, hey, I need to find my k. But first, you have to be like, okay, I know this is direct variation because it says varies directly or it says directly proportional. So like directly varies directly proportional, something like that to give you a key and be like, okay, direct variation. First step, find k. Second step, you're going to write the equation. And then the third step, you always solve the problem, okay? So same thing here, you're going to, basically you want y equals kx, you want y by itself. So you go ahead and you solve for y, and this is just kind of review from graphing because you know how to graph and you've been graphing before. And then here with these graphs, again, you want to find k, write the equation, solve the problem. So the first thing I did was I found my k, but remember k acts like the slope. So that's why I found the slope, and then that was my k value. So then I got my equation, y equals something x, and then I just found the value of my x by just tracing it along my line. Again, direct variation is one of those things that's we do tend to miss often. It's just because it's one of those smaller things that we don't really talk about too much because it's our only lesson over it. But if you have any questions, please feel free to come in for tutoring.